So here is another question on graphical analysis of one-dimensional motion. So here it is given that the figure below, this one, it shows the distance time graphs of two trains which start moving simultaneously at the same time, the same direction, and from this graph we have to find first how much ahead of train A is B when motion starts. What is the speed of train B? When and where will A catch up with train B? Okay, and then what is the difference between speeds of A and B? Okay, so first here from this graph at the beginning at t equals to 0 hours, this point, the distance traveled by train A is 0 at t equals to 0, and the distance traveled by train B is 100. So at the beginning of the observation at t equals to 0 hour, distance traveled by B is already 100 kilometers, while distance traveled by train A is 0 kilometers. So B is ahead of A by 100 kilometers. Okay, that is the first bit. Then we have to find the speed of B. So we can do that from this curve B. Okay, so let us name them. Let us name it, let's call this P, this intersection point Q, then okay, this one R. Let's see where the need of it comes. Okay, so let us now focus on this PQ portion of PB curve. Okay, the displacement or distance time curve of train B, the PQ portion. From this PQ portion we have here is the final distance SF in this PQ portion, that is from 0 hour to 2 hours. So speed of V from the PQ portion, that is final distance minus initial distance by final time minus initial time. So here in this PQ, the distance traveled at this point Q is 150. Initial distance at t equals to 0 is 100. Final time is 2 hours. Initial time is 0 hour. Okay, this here. For train B we are talking about 2 minus 0, that is equal to 50 by 2, which is equal to 25 kilometers per hour. That is the speed of train B from this curve PB we have calculated at this point Q. This the distance or displacement at this point Q, at this intercept point Q, is 150, time is 2 hours. At this point P, the initial distance traveled by train B, that is 100, at time t equals to 0 hours. So simply put the values and got the result. The slope of displacement time graph that gave us the velocity or speed of train B. Then it has been asked when and where will A catch up with B. So it is at this intersection point Q where the distance traveled by both train A and train B is same. At this point Q, the distance traveled by train A is equal to train B, and that is equal to how much? 150 kilometers, and the time that is equal to 2 hours. Time t equals to 2 hours. So A will catch up with B at a distance of 150 kilometers, or displacement because it is traveling in straight line, so same thing, okay, displacement after 2 hours, okay, at this point. This is the third bit, and then we have to find what is the difference between speeds of A and B. So speed of A we have to calculate from this curve OA, from this OQ portion, okay, from this OQ portion. So from OQ portion, speed of A is equal to final displacement, okay, which is equal to this portion. From OQ it is 150, initial is 0, final time that is equal to 2 hours, initial time is 0, that is equal to 150 by 2, that is equal to 75 kilometers per hour. So A is traveling faster than B, and the difference between speeds of A and B, that is equal to VA minus VB equal to 75 minus this is 75 minus 25 kilometers per hour, that is equal to 50 kilometers per hour. That is the difference of speeds between A and B. A is traveling faster to B with by 50 kilometers per hour. Okay, this is the solution. Okay, simple basic question for interpretation of different parameters from a displacement time graph. So here is another question on graphical analysis of one-dimensional motion. So it is given that a train moves from one station to another in 2 hours time, and the speed time graph during the motion of the train, it is like this, okay, time in x-axis, speed in y-axis, and from this graph we have to find the maximum acceleration during the journey and the distance covered by the train during the time interval 0.75 to 1 hour. Okay, so now let us first mark the different points on this graph. Starting from origin O, let this be A, this be B, this be C, this be D. Now if you see the BC portion of the graph, it has the maximum slope, steep slope. So obviously this indicates maximum acceleration because it is speed time. So slope of this BC, it will give the maximum acceleration. Okay, that will give us the maximum acceleration. So that will be equal to acceleration during BC, final velocity minus initial velocity, final time minus initial time. So here the final velocity, it is equal to 50 kilometers per hour, initial velocity at this B point, that is equal to 20, then final time from this BC here, it is 1, and initial time at this B here, it is 0.75. 5, that is equal to 30 by 0.25, that is equal to, it is coming around 1 by 4, it will be 120 kilometers per hour square. That is the maximum acceleration for this curve during the it is the BC portion. That is the first bit. Then it has been asked to calculate the distance covered during the time interval from 0.75 to 1 hour. So this is basically from here to here, it is the area of this portion. So basically it is the area of the trapezium, if that is equal to ABCD and this be E, let's name this E and this F. So the distance covered from t equals to 0.75 to t equals to 1 hour, it is the area of trapezium BCEF, that is 1/2 into sum of parallel sides, that is BE plus CF into EF, that is equal to 1/2. BE is equal to 20, CF is equal to 50 and EF is equal to 1 minus 0.75, that is equal to 0.25, that is equal to 1/2 into 70 into 0.25, that is equal to, it is coming around 8.75 kilometers. Okay, 8.75 kilometers. So this is again a simple interpretation of the graphical analysis of one-dimensional motion. Okay,